Hi everyone, Assalamu alaikum. Hope so you all are fine. So now in this lecture we'll talk about TCP header. So what really this TCP header is? So TCP basically means transmission control protocol, and it is reliable transport protocol as it establishes a connection before sending any data, and everything that it sends is acknowledged by the receiver. In this lesson we will take a closer look at the TCP header and its different fields. So here what it really looks like, you are seeing it's on your screen. So let's first talk about this source port, what really this source port is. Okay, so this is a 16-bit field that specifies the port number of the sender. So this is the 16-bit field which really specifies the port number of the sender from where the message is sending. Okay, so this means a source of a sender. Another thing here is the destination port. So by name it is showing that basically this port will show the destination where the message is going. So this is also a 16-bit field that specifies the port number of the receiver. So another thing here you are seeing around is the next thing here is the sequence number. This sequence number is a 32-bit field that indicates how many data is sent during the TCP session. So this shows that how much data is sent. When you establish a new TCP connection, that means a three-way handshake, then the initial sequence number is a random 32-bit value. So basically the initial value of the sequence number is 32-bit. The receiver will use this sequence number and sends back an acknowledgement. Protocol analyzer like Wireshark will often use a relative sequence number of 0 since it's easier to read than some higher random number. So I will show you in the last of this lecture some snapshots from the Wireshark that will tell you about what really the sequence number is and acknowledgement. This whole header file, this whole header field, how the numbers and things are showing. So let's come to the second field, which is the acknowledgement number. So basically acknowledgement number is also a 32-bit field and is used by a receiver to request the next TCP segment. This value will be the sequence number incremented by 1. Let's come to another point, which is data offset. So data offset is basically 4-bit data offset field, also known as the header length. So basically it tells you the header length. It indicates the length of the TCP header so that we know where the actual data begins. So there are some bits available that tells you the sequence of bits, basically tells you the start of the message. And then there is a reserved, you are seeing here it's called reserved. In general life you can say reserved, or what really the reserved mean is. So basically the reserved means is, okay, so it is kept for something particular stuff. So basically there are some bits that are available that might be in reserved. These are 3 bits for reserved field. They are unused and are always set to 0. Then we will go for the flags. So these all are called flags. So there are 9 bits for flags, 9 bits of flags. So let's come to see what really these are. We always say that there are 9 bits for flags, and we also call them control bits. We use them to establish connections, send data, and terminate connections. So first is the CWR, is basically called the congestion window reduced. It is a flag which is set by sending host to indicate that it receives a TCP segment with the ECE flag set. So these both are the parallelly working, like segment with the ECE flag set added to the header, and its RFC is 3168. So ECE is basically an echo. It indicates that the TCP peer is ECN capable during 3-way handshake added to the header by the same RFC 3168. URG means urgent. You can note down these things. I will just orally tell you about this. URG means the urgent bit or the urgent pointer. When this bit is set, the data should be treated as priority over other data. So this is set, then it's priority over other data. So you know about ACK. ACK basically means the acknowledgement. It is used for the acknowledgement. So PSH basically means by push. So this is the push function. This tells an application that the data should be transmitted immediately and that we don't want to wait to fill the entire TCP segment. Then there is an RST, which really means reset. So this reset the connection. When you receive this, you have to terminate the connection right away. When you receive this bit, what you will do is you have to terminate it right away. Okay, you have to terminate the message right away. This is only used when there are unrecoverable errors and it's not a normal way to finish the TCP connection. So the next thing is sync. So you know what really sync is. It's just normal and common in use. We use this for the initial three-way handshake and it's used to set the initial sequence number. So it is basically used for initializing or initial sequence number. Like if I am connecting with you, what really happen is at first it is syncing, like communicating or connecting. So basically the first step here is the sync. When this bit is 1 or this bit is true, then this means the connections are established. Okay, so we call this as the initial sequence number. And then here is a fin. This means this finish bit is used to end the TCP connection. TCP is full duplex, so both parties will have to use the fin bit to end the connection. This is the normal method how we end the connection. So I hope you understand this. So now let's come to the second thing, which is window. So what really this window is about. 16-bit window field specifies how many bytes the receiver is willing to receive. It is used so the receiver can tell the sender that it would like to receive more data than what it is currently receiving. It does so specifying the number of bytes beyond the sequence number in the acknowledgement field. I hope you understand this. So the last thing here is the checksum. So basically checksum is we already learned about this thing in previous lectures, what really checksum is. So let's do the same thing again. Like it's a 16-bit and used for a checksum to check if the TCP header is okay or not. Basically it is used for the checking the errors. We already learned this in previous lecture in detail. So I hope you understand this. So what really this urgent pointer is. So this urgent pointer is basically 16-bit and is used when the urgent bit, this urgent bit has been set, the urgent pointer is used to indicate where the urgent data ends. So basically it will tell you from where the urgent data is started and from which point the urgent data ends. And the last thing here is the option and padding. As it's the optional, whether it is you can add it or whether you cannot, it's up to you. It already it presents in almost all the headers. So like we already learned it in MAC header and in IPv4 header, and now it's the TCP header. Checksum, option, window, these are flags, destination port, source port, all have the same properties as I told you in my previous lectures. So basically this field is optional and can be anywhere between 0 and 320 bits. So you are seeing here this is a frame. Okay, so this is a frame and here you can see about this thing. This is the source port, the destination port, and then here is a sequence number, acknowledgement number, header length. So this is all about the flags. These all are the flags like reset, push, acknowledgement, urgent, echo, congestion window, nonce and reserved. So we will see what really nonce and reserved are. And here you are seeing it's sync. This means now the connection is established and now we are going to connect and now we will move further. Okay, and there is a window size value of 4128. So they are calculated the window size here, and here is a checksum which show the validation is disabled. This means there is some issue, might be good checksum is false and the bad checksum too is false, and there is an urgent pointer which is 0, and the option here is 4 bytes maximum segment size, and maximum segment size is 1460 bytes. So maximum segment size with the length 4 and its total value is 1460. Above this you can see the source and destination port. The sequence number is 0, but Wireshark tells us that this is a relative sequence number. In reality it's something else. You can see the sync bit has been set in the flags, the window size, checksum, urgent pointer and options. TCP is a complex protocol, but I hope this lecture will help you to understand what the TCP header looks like. If you have any question, feel free to tell me in the comments and follow me further. I will tell you more about the things, because now on the lecture is going so interesting, because after this we will talk about the attacks. So good luck for the next lectures and Allah Hafiz.